Hello, today we'll be looking at the Hooke's law experiment. So first of all, this is the apparatus, right? This is the apparatus. We have our measurements. So this is our measurement. This is our measure, and then this is our spring. This is our 3 Newton spring, and then this is our 20 Newton spring, and then the mass. This is the mass. So 3 Newton spring, and then the number of turns or coils here is more than this. So these are 20 Newton spring, and these are 3 Newton spring. So first of all, we hang this here. We hang this here like this, right? We want to measure the elongation, right? The extension or the elongation in the various springs. So first of all, we hang this 3 mass. We start with 10, right? So 10. We start with the mass of 10, right? So we hang this here. We are not measuring oscillation, so we don't want this to be oscillating up and down, right? We don't want the oscillation. We are measuring the elongation. So you realize that we set this to 0. So this 0, the tip of this spring is where this starts from, because this tip measure starts from 0, right? So we want to check how it elongates, or the extension in this spring when we have 10 grams of mass on it, right? 10 grams of mass on it. So we start with 10 grams. We hang it gently, and then make sure it stops. Then we measure the elongation, right, in centimeters. So this is how the table looks like. So 10, and then so this is the table. We have, so right here we start with 10, right, for the 3. So this is a short spring, right? So 10, and then we write the distance here, right, the length. Then we increase this to 20. Then we increase this to 20. Then we increase this to 20, and then we record. So here the next one will be 20, then record the extension. Then we increase this, we further increase this, then we record the extension, right? So that's what we'll be doing for the first spring. When we finish, we remove this, and then introduce the 20 Newton spring as well. Then we set this to 0. So we have to increase the length of this so that it starts from the tip, right? Then we start with 10. So this for the first spring. This side is for the second spring. So we hang the second spring as well. We measure the elongation in here. So that one too, we start on 10, then the extension. Then we go to 20 and the extension. So we finish for all the 5 values, right? So that's how we'll be doing it. Now, let's look at the theory behind. Now, they are saying that this is our formula, okay? So this is the formula, okay? So X is supposed to be the extension, and then this is supposed to be the spring constant. X is the extension, and then K is the spring constant. So this is the formula. So when we check the post lab, they said we should plot the dependent variable against the independent variable. So the meaning of this is that we know force needs acceleration and the mass and everything to act. I mean, force cannot be force unless we multiply mass times acceleration, right? So whatever, so for force we multiply something to get something. So force is dependent, but for the elongation, right, change in L is independent. L is L. We don't multiply anything to get L. We don't do anything. L is just L. You measure L, that's it. So we'll be plotting two graphs. We'll be plotting two graphs, right? One for this and then one for the long. One for this, one for the long. So our force becomes the dependent, and then our change in L extension becomes the independent. So this is the formula we'll be using. We are plotting this against this. So when we equate that to equation of a straight line, this will be having y as our f, m is minus k, and then L is the extension. So like I've written here. So after plotting our graph, we find the slope, right? Then we come and equate the value of a slope to minus k. It means if you want to find k, right, k becomes the negative of the slope. So that's how we find the spring constant for this particular spring. So we'll do for the first one. So you have to find two slopes because we are plotting two things, right? We'll plot one for this and we plot one for the other one here, right? So the line, our graph will look something like this, right? Our graph looks something like this. We'll find slope for the first one, then equate it to minus k, then we find the spring constant for the first one. Then the second one too, we'll draw the graph, find the slope for the second one too, then we find the k for the second one, right? Okay, so that's for this experiment. Now when we finish, we are supposed to compare the spring constant that we obtained in the two k's that we got, and then we can do our discussion based on that. Which one has more extension? Which force gives more extension? Okay, so that's how we do this experiment. So the things we need once again are two springs and a mass, and then whether a ruler or tape measure or whatever you want to use to record the elongation, and a stand. So once your lab has a stand, a tape measure, and the springs, that's it. Thank you very much.